So let's start with direct and inverse variation. So direct, suppose you have these values x and y. Direct variation means uh, like if you divide them here, 12 divided by 3, 16 divided by 4, in each of them you are getting 4 4 4. On dividing you are getting a constant value, and
So
in this
direct is
table,
y over. So
hmm,
direct is y over x, and inverse is x times y.
yes. So in case of direct, you are getting constant by dividing, and inverse, you are getting constant by multiplying. So d for divide, d for direct. This is how you can remember. This is for direct, y over x is equals to constant. Inverse is x times y is equals to constant. Okay,
Yeah.
let's see some questions. So if y varies directly as x and y is 14 when x is 5, find y when x is 3. So 14 divided by
Okay.
5.
So wait, let me try this.
Okay.
So if it's directly, then I have to do y over x. So 14 over 5 equals x over 3. So I'd multiply 14 and 3 to get 42 equals 5x. I divide both sides by 5 and I'd get 8 and 2/5 equals, wait, no, 14 over 5 equals y over x. Um, yeah, so then whatever 14 over 5 is equal to would just be my y over x, I think.
Yeah, 14 over 5, 2.8, and then you times it with 3, right?
Yeah.
Yes, exactly. This is what you have to do. And now, is this the same one? Try this.
Okay. So, do y equals 5 when x equals 14. Find y when x equals 12. So y over x would just be 5 over 14. So 50 equals 14x, right?
50 over 14x. Yes, 50 over 14, right?
Yeah.
Yeah, that's correct. This one,
Um. So inversely as x squared equals y over 5. When as x squared y equals 5 when x equals 6/5. Find y when x equals 2. So I'd get 2 times y equals 4. So y
okay.
equals 2.
Did you not square this 6 fifth because it is x square there?
Oh, so I have to do. So y 1/6 squared? I don't know what that is.
Because it says y varies inversely as x square. So the value of x you have to square it. 6 fifth square times y. On multiplying these two you will get constant. So what you need to do is So y is varying inversely with x square. So yx square is equals to whatever we get here. This is equals to um, because y is 5 times x is 6 fifths, so 6 square is 36 over 5 square is 25. If we solve it, we will get, I think, 7.2, because this will become, yeah, 7.2. So now we have to find y when x is 2. So this is going to be 2 times y is equals to 7.2. So y will be 7.2 divided by 2, because when x is 2, so we divide it by 2, and this will be our answer. And
So I do 5. Wait, can you go back up so I can see?
yeah,
Sorry.
yeah.
Just want to read over. So 5 times 6 fifths squared equals k. So apparently that's equal to 7.2. So 7.2 equals k. So then I'd get um. So what I do from 7.2 equals k. What would I do from there? Y equals
You will
k
divide
over.
7.2 by 2 square, because you have to find y when x is 2, because x is square, so 2 square is 4.
Okay. So then I just get whatever 7.2 divided by 4 is. Okay.
Yeah. So for direct proportion, we always get a straight line graph, and indirect is like this. It goes, indirect means if one values goes up, the other goes down. And direct means both goes up or both goes
Yeah.
down. Let's try this question. Yeah, try this.
Okay. So 4 people do a job when it takes 8 hours. So this is inverse
Yes,
or
it is.
indirect, I guess. So we would
Inverse.
multiply, which
Yes,
means we
multiply.
would do 4 times 8. No,
Yeah. Yeah, 4 times
4
8.
times 8 equals 7 times x. So 32
Yeah.
equals 7x. So I divide by 7, and whatever is 32 over 7
Yes,
is equal to
absolutely
would be my
correct. Yeah,
thingy.
32 divided by 7 will be your answer. Okay. And this
Okay.
one?
Uh, so there are 10 people. Food can last 8 days. Suddenly 3 people got injured. How long will the food now last? So indirect, right? Because the less people there are, the more food
Yes.
there is.
Yes, indirect.
So we would multiply,
Yes.
and we'd get 10 times 8 equals 7 times x. So we
Yes,
get,
exactly. Yeah.
what, 80 over 7?
Yes, 80 divided by 7 will be your answer, which is 11 point something days. Okay, great.
Okay.
So, what about this one?
Uh, a car can try 11. Oh, so this is direct. We would divide. So we do 11 over 2
Hmm.
equals 9. So we'd get 22 over 9. No. So 11 over 2. So we'd get 5.5,
Hmm.
should equal 9 over x. So
X over 9, okay? 5.5. is equals to x over 9. Always reverse it.
Okay. So then I just do 5.5. So I just do 9 divided by 5.5.
Times. Because see 5.5 times 9, right? You are doing 5.5 is equals to x over 9, right? So 5.5 times 9 will be x, right?
Yeah.
Hmm. So you have to just remember, like in this one, whenever you have direct variation, this will be not 9 over x, it will be x over 9. So the values goes down, okay?
Yeah.
Like here you are writing 11 over 2, so this will be x over 9 because 2 liters you are writing down. So this is also given in liters, so this will be in denominator, bottom. Let's do this one.
Okay. So inverse.
Yeah,
No,
inverse.
direct. Wait. Oh yeah, because more painters, less days.
Yes.
We multiply and we get 24 equals 10x.
Hmm.
So we just do 24 equals 10x.
Yes,
Uh, yeah, we just do whatever that's equal
exactly.
to.
24 divided by 10, right? Okay, good.
24 over 10? Wait, I thought it was 10 over 24.
Because 24 is equals to 10x. So x will be 24 over 10.
Oh, yeah, yeah, oopsies.
Hmm. Next one, this one.
So this is direct, and then we divide.
Yeah.
So we do 10 over 3, which equals 3.3, should equal 4 over x. So we'd get 4 over 3.3.
No. X over 4, isn't it?
X over 4?
10
Oh, so
over
it'd be
3.
3.3.
Yeah, because in
Oh,
direct,
yeah.
you can remember like this because see, you are writing 10 over 3 and these are hours. So hours should also go in bottom, right? If you are writing 3 in denominator, 4 should also go in denominator. This is hours, time. Both of them are time, so both of them will go in denominator. So 10 over 3 is equals to x over 4, right?
Yeah.
Hmm. Okay, like this. Okay, let's do this one, last one. Yeah.
Okay. So it takes 3 water pumps 4 hours to fill a pool. If there are 5 pumps, how long would it take to fill the pool? So this is indirect or inverse.
Yes. Yes.
So we'd get 12 equals 5 times x. So whatever 5 whatever you have to multiply 5 by to get x
Yeah,
is my
12
answer.
divided by 5. Yeah. Okay. Yes, that's correct. Let me just close it. Okay, so for binomial theorem, um, you should know how to make Pascal triangles. So we start with 1, then 1 1, and just add two adjacent values to get the next value, right? 1
Okay.
plus 1 2, and this, and each of them correspond to
I just
fixed
started at
power.
14641 and I
Yeah,
worked
this is 4.
my
Okay.
way up.
Yeah, you can go backward or forward using that, right? So whatever is the power, like fourth power means you need just this row and you should know the coefficients. And first term we take maximum power like y to the power 4, and second term we start with 0, and then first term we will decrease by 1, second term increase by 1, right? And just expand it.
Yeah.
That's it. So can you try this one? Yeah, let's try this one.
Okay, so 14641. So I get n to the power 4 um, plus n to the power 3 plus 3 plus n to the power 3, n to the power 2 plus 9 plus n to the power 1 plus 27 plus 81.
27 plus 81. Okay, let me see. Okay, I think this, if you cube 3 and then times it with 4, this will become 108. Okay, so I think yeah, and if it is asking a coefficient of any specific term, you have to take care of sign, okay, and all the constant will be the coefficient. So let me just then log. So to convert an exponential function into log, like when we have bx, so base goes here and this thing we write here, and exponent we write right side of the log, right? Like bx is equals to a will be log base
Yeah.
a is equals to x. Now basically I need to show you the properties of log. I know you can do this one. So if there is no base, you have to consider 10, which is called common log. Okay. So properties of log is, first is product property. If they are in multiplication, you will convert them into addition. Okay, like m times n, and when you are converting, you have to I write log with each of them, log a m plus n. If they are in division, this converts into minus sign. Okay, like log m
Yeah.
minus log a. If there is next one is, if there is a power like this power goes in front of log. Okay, like here this n comes in front of log. Then inverse log means if this base and this is same, then the exponent is your answer. Okay, like here 8 is same, so the answer will be just 2. Okay.
Okay.
Hmm. So yeah, so for example here we have log 20, so we can write it as log 4 times 5, and log because this is in multiplication, we can convert it into addition, and here
So
it is
log
in
4
division.
equals 6.602 plus 699. Then I just add them up. Okay.
Yeah, so these are the properties. Okay, you should remember these properties. Okay,
Yeah.
and if the power, if you have given some square root, you can write it as x to the power 1 half, and then you can take this power in front of log. Okay,
Yeah.
for example here question number 2, we have to expand it. So they are in multiplication, we can write it as log a to the power 5 plus log 3 square root b, and the one which is in denominator, for that we put minus sign, right?
Yeah.
And you can see when we remove this square root, we put 1 half in front of log, because power goes in front of log according to the property of log. Okay,
Okay.
and when base and this number is same, our answer is just exponent.
So wait, can you go back up so I can just look at it for a
Yeah,
second longer? Sorry.
yes, yes.
So log A. Okay.
Hmm.
Um, wait, what does the purple one mean? So
It,
equals
it means if you have
x.
log base 8 of 8 um, to the power 2. So the answer is just 2. If this base and this number is same, so the answer is just exponent.
Oh, okay.
Hmm.
So log base 8 of 2 equals 8. But that doesn't make sense.
Yeah, I'm just telling you if this part is same as this, then this is equal to exponent. Okay, this is what it
Oh,
means.
okay.
Log base, this is a and this is a and this is, let's say, x, so the answer is just x. So yeah, I think you are able to do this. Maybe. Yeah, so for graphing rational functions, this is important. Okay. So we need these things: first holes, then asymptote, then intercept, and then sign analysis. So for holes, what we need to do, if we have same top and bottom thing, if they are cancelling, that is called holes. Like in this number, in this fraction, there is no hole because denominator and numerators are different, right? So hole is none here.
Yeah.
Asymptote can be vertical, horizontal, and slanting. So for vertical, just put denominator is equals to 0. Like here, if we make denominator 0, we get x 0 and x negative 3, right? So x 0 is this
Okay.
and x negative 3 is this. Now let's see how we check for horizontal asymptote. Horizontal asymptote, um, there are three things possible if denominator degree is greater than numerator. Like here we have 5 and 3. So this is y is equals to 0. If degrees are same for numerator and denominator, just divide the coefficient. If numerator is greater, then there is no horizontal asymptote. In this case, um, as you can see, denominator is greater than numerator, right? So
Yeah.
y is equals to 0 is horizontal asymptote. Okay.
So horizontal asymptote is I set. So okay. Horizontal asymptote is I don't know none. How do I check the vertical asymptote? Do I just set the bottom equal to 0?
Yes, bottom equals 0. Yeah. Like here, x 0 and negative 3, if you set equal to 0. And because
Okay.
denominator is greater than numerator degree, so here horizontal asymptote is y is equals to 0, right?
Yeah.
And what about slant asymptote? If numerator degree is 1 more than denominator, like here 3 and 2, 3 is 1 more than 2, then you have to divide them using uh, like we divide um, polynomials. The same way you have to divide for slanting asymptote, and you will get a straight line equation. You have to plot that. Okay.
Okay.
So for x-intercept, put y0. So here there is no solution because 0 equals 1. That doesn't make sense. So no solution. Now you have these, whatever asymptote you are getting, just keep plotting them side by side. And then after that, get x and y intercept. If there is any xy intercept, plot that. Now you have to do sign analysis. Both side of asymptote, like here we have x is equals to negative 3, so put x is equals to negative 4 in the function, and at that point you can get the value of y. Okay, then right side,
Yeah.
like we have negative 3, so put negative 2, and then you can take 1. So around all the asymptote, both side you have to plug values and check. If it is going, if it is positive, it will go in the upward direction and right side. If it is negative, it will go downward. This gives you an idea, but you can take the exact values also. Okay.
Okay.
Yeah. For example, here, first you factor it, numerator. If you factor, you get this x minus 3x plus 2, right? And
Yeah.
x plus 2 and x plus 2 is cancelling. So whole is x is equals to negative 2, right? Okay. If you check, degrees are same, x square and x square. So what will be horizontal asymptote?
Horizontal asymptote is 1/2.
Yes, y is equals to 1 half. And vertical, for vertical just set denominator is equals to 0, and which will make x is equals to 2. So x is equals to 2 is vertical. Okay, then you find
Oh,
x
okay.
and y intercept, plot them, and both side of asymptote try to get the values and just plot it. And then
Sorry, can you say it again on this? Do you just want me to evaluate that? Okay.
this one, no, no,
Do you
not
want me to
this one.
evaluate that one?
No,
Okay.
uh, I opened it by mistake. Hmm. So for log functions, uh, asymptote is what is inside parenthesis with log. Like here, asymptote is x is equals to 1. You have to flip the sign. If it is negative 1, asymptote is positive 1. Okay, so x is equals to positive 1. First, we make here asymptote, and after that, to solve it, we need to consider values which make our calculation easier. So log 1 is 0, and when log base and this log of that value is same, the value is 1, so log 1 is 0. So we need to make it is equals to 1. So x minus 1 is equals to 1. If we set it equal to 1, x will be 2, right? So if we put
Yeah.
here 2, this will become 1, which is log 1 is 0, so y is 3. So we plot it, and other value we can get by making this base and this parenthesis value 3. If base and this thingy which is inside parenthesis, if they are same, the value of log is 1. So log 3 of 3 is 1. Okay, so that's why we will make this what is inside parenthesis is equals to 3, because our base is 3. So this will give us x4. If we put x4, we'll get
What
corresponding.
if,
Hmm.
so if the thingy's on the inside, x equals 1. Wait, but don't I have to add the 3 to it? Like,
Yeah,
if it
you have to.
equals, okay.
That's how I got y3,
Wait, so wait. What if x minus 1 equals 1? Does that equal, what does that mean?
because we have to make it 1, because log 1 is 0.
Oh. And then what does log 0 mean? Like,
This value will
log 3
vanish.
is,
So we will just get
so it's
3.
just going to be the y value. Okay.
Yeah, yeah, it's gonna be y value. So just remember asymptote is this. Also, you have to plot it vertically like this. It will be a vertical line. Okay, you can remember
Yeah.
like this. This is x. So this will give you x is equals to 1. On x-axis you have to draw. If you draw it like this on y-axis, that will be wrong. On y-axis we
Okay.
draw in case of exponential functions. Okay, so what is asymptote here?
Asymptote is positive 2.
X is equals to 2, yeah. So you will draw it on x-axis. Okay,
And then there's another one too, though, right? The horizontal asymptote would be 5.
no, it's
Oh,
just 2. Okay, 5 is not asymptote.
okay.
There is no horizontal asymptote in log graphs. Okay, That is only in
Oh,
rational one and in exponential function. There is no horizontal in log. What
okay.
is uh, asymptote in this case?
Asymptote is positive 4.
Yes, positive 4. And so in log functions, range is always from negative infinity to positive, because you can see the graph is going like this, right? So all y values.
Yeah,
Range is always negative infinity to positive. Domain is where your asymptote is to, like here it is going towards positive x-axis. So 2 to infinity, right?
yeah.
Let's start with asymptote.
So what happens if my like log? What if it's like negative log 5? What does that mean?
Negative, like here, we have also log this.
Yeah.
Y- uh, you don't need to care about negative sign. Okay, just plot it, follow the same steps. You will get the graph. You like it flip. Okay, if you just follow the steps, just plot
Yeah, but how
asymptote.
does the negative influence it? Do I, if I get a 1
Yeah.
plus 1, do I just get like, if I get log um
Mm-hmm.
2 of 2 and I get 1, do I change that 1 to be a negative 1?
Okay, if you are, suppose you put here x5. Okay,
Okay.
5 minus 4 will make it log 1, right?
Yeah.
Log 1 is 0, so negative doesn't matter here. But if suppose
Okay.
you put 6
Yeah.
and 6 minus 4 is 2, so log negative log 2 of 2, so log 2 of 2 is 1, okay? But you have to put
Okay.
negative outside it because negative is there.
Okay.
So this will become negative 1, positive 1, which is 0. So yeah, you have to consider negative. And if you want to
Okay.
see
So,
the effect on graph, yeah, so graph will
okay.
flip. This shows reflection.
Okay.
Hmm. Follow all same steps, put negative sign there. When you are putting values, you have to consider negative sign. So yeah, now let's see exponential function. So in exponential function, whatever is other than exponent, this part like here plus 3, this is your horizontal asymptote. Y is equals to 3.
Yeah.
So yeah, y equals 3, and then you can put x values. You can choose x0 because we know anything to the power 0 is 1, which will make it 1.
Okay.
And accordingly you can put values, like if you take x1 you will get y5 and just plot it, asymptote, and the graph will go like this. Okay.
So, wait. Can you go back to it? So, x equals 0. So, y equals 4. Okay.
Hmm.
Okay, I got it.
Yeah, if there is no asymptote, you have to draw it on 0. Y is equals to 0. Okay, like in this case there is no
Okay.
asymptote, so it will be y is equals to 0. Okay.
Okay.
Hmm. What is asymptote here?
Asymptote is negative 4.
Yeah, so remember, in exponential function we are not changing sign. If it is negative 4, we are keeping it negative 4. But in log, we are changing sign, right?
Yeah.
If it is x minus 2, asymptote is x is equals to 2. But here, sign remains same. So in exponential function, by from graph you can see all x values are allowed values. So domain is from negative infinity to positive infinity, but range is from asymptote, like here asymptote is negative 4 and graph is going in the upward direction, so negative 4 to positive infinity, right?
Okay. How do I figure out the domain and range of like a statement? You know how if there's like a statement and it's like y equals the square root of x plus 4, and then not while it's in the parentheses, not under square root, it's like minus 4. How do I tell the domain and range if it's like that?
Okay, let me go here. So you mean if there is a number, can you give me one example?
Yeah, sure.
Hmm. Like a
So,
question, not example, a question.
y equals square root of, I don't know, x plus 4.
Okay.
And then
This.
not inside the square root, it's just minus 5 or something. How would I tell the domain and range of that statement?
Okay. So domain, for domain, whatever is inside square root, this should be greater than and equal to 0. Okay. Put it equal to greater than and equal to 0. Now, so what will be x? X will be greater than and equal to negative 4, right? If you solve it, this is what you will get.
Oh, okay.
So domain is from negative 4 to positive infinity. And negative
But
4 is
why is
included.
it? How can you automatically tell that x plus 4 is greater than 0 just from that?
Because if you have any value which is negative inside square root, this gives you imaginary values, right? Remember iota?
Oh,
And
yeah.
domain
Okay.
means the values which are real, which give us real answers. So that's why.
Okay.
Um, yeah. And for range, what you need to do, range means all possible y values. So range, for range you have to put whole thing square root of x plus 4 minus 5 greater than and equal to 0,
Okay.
because this is whole y, right? This is whole y thing.
Yeah.
So if you make it greater than and equal to 0, okay, so if this is y, and okay, this will become x plus 4 greater than and equal to 5. No, no. So smallest possible value here we have negative 4. So if this is equal to 0, I mean greater than 0, mm, so I think, okay, okay, you don't need to do this whole thing. Just look at this value which is other than square root, okay? Negative 5. So all the values which are greater than and equal to negative 5 will be range, okay? This.
Yeah.
So all values which are greater than and equal to negative 5. So basically negative 5 to positive infinity is range.
Okay.
Yeah. So for domain, just check the square root part, and for range, check what is without square root.
Oh, okay.
Hmm. So, okay. Hmm. In this case, what is asymptote?
Asymptote is equal to negative 1.
Yes, y is equals to negative 1. Okay. And again, if you have 3 or x minus 2, anything like that, just keep everything same. But when you are putting x and finding corresponding values of y, you have to consider all these values.
Yeah.
Okay. Okay, so when you have these type of questions, Look at the denominator, like you have a fraction power 2. Try to convert this 49 into power of into a number, into its power of 2, like 7 square, so that this fraction can cancel, right? Like
Okay, so it'd be like 240. So it'd be 343, and then you'd do like
yeah,
um. Wait. So then V cancel, and you just get 3. So you just get 1. So 243 V to the power 1,
v to the power
or V to
9,
the power 9. Oh, okay.
because this 6 and 2 will cancel, which will give us 3, and 3 times 3 is 9, right? This is what we have.
Yeah.
This one,
Um. So we just get 5 squared, and then we just get 5, and then we get 5x to the power 2.
yes, 5x to the power 2. Good. This,
Um, 6 squared, so I get 6 cubed, and then I'd get n to the power 6. So 243 n to the power 6.
yes, 6 cube and to the power 6. Okay. This one,
Yeah. You'd cancel. So you'd get 3 to the power 5, so you'd cancel, and you just get 27 n to the power 3.
yeah. Okay, good. So I will ask this one also. Convert this into log.
2 to the power 7 equals x minus 2. So 47. So whatever 2 to the power of 7 minus 2 is x.
Yeah. So you can, okay. Convert this into log.
So 2 to the power 3 and 8 to the power and 2 to the power. Wait, what am I saying? Convert to log. So log 3 of 8 equals 2r. Then I just get log 3 of 8 over 2 equals r.
Yes. Okay, good. Convert this into exponent.
Um, what did you say, miss? So 3.
Convert it into exponential
Oh,
function.
okay. So 2 to the power 3 equals x.
Yes.
So
Okay,
x
great.
equals 8.
Okay, great. Let me stop here. So, do you have any question?
Nope.
Okay, then bye. Good luck.
Thank you. Bye.